Okay, let's dive into this. Welcome to this explainer where we're going to completely crack the code on what your truck's check engine light is actually trying to tell you. Look, whether you're a seasoned driver, a fleet operator, a beginner diesel tech, or just someone who loves getting into the weeds of diagnostics, mastering these top 10 fault codes is literally your ultimate superpower for keeping your rig on the road.
Now you know that feeling, right? You look down at the dashboard, see that flashing warning light, and just feel an immediate wave of stress. We almost always view those lights as just super annoying nuisances. But let's shift our perspective for a second. These codes aren't just there to ruin your day. They're actually crucial, highly specific cries for help from your vehicle. By understanding exactly what your engine, emissions, and electronic systems are flagging, you can prevent incredibly expensive roadside breakdowns and those absolutely dreaded engine derates.
So, here is our roadmap for today. First, we'll look at decoding the codes, then emissions and aftertreatment, third, engine air and coolant, fourth, sensors and drivability, and finally, smart diagnostics. Starting off with Section 1, decoding truck fault codes.
Whenever you plug a scanner into a Cummins, Volvo, Freightliner, or Mack engine, you're immediately greeted by this massive alphabet soup. But honestly, it all boils down to two key acronyms. The SPN, or Suspect Parameter Number, identifies the exact component that's acting up. Think of it as the WHO. It might be a specific temperature sensor or a fuel injector. Then you have the FMI, or Failure Mode Identifier, which tells you the what. Like, is it a short circuit? Is it an abnormally low signal? Understanding this pair is the absolute foundation of all truck diagnostics. It's like a giant puzzle, and these are your corner pieces.
Moving on to Section 2, emissions and aftertreatment systems.
Now, what's really interesting about this is how these critical aftertreatment codes all tie together. The DPF, DEF, and SCR systems have to work in perfect harmony to clean your exhaust and protect the environment. But the moment one of these sensors flags an issue, the engine computer's immediate response is to protect itself, usually by limiting your speed and power. Let's look a bit closer at a few of these bad boys.
Take SPN 3719, for example. This means your diesel particulate filter, or DPF, has a high soot level. If you see this popping up with an FMI 16 on, say, a Peterbilt or Kenworth, your computer is actively derating your engine power to 85% and basically begging you for a part regeneration. But if you ignore it, well, at FMI 0, your power is severely slashed to just 50% and you're forced into a much longer recovery region. At that point, the truck is literally suffocating on its own soot. Then we've got the infamous SPN 52466, which deals with the DEF or AdBlue system. And here's an absolutely crucial pro tip. This is very often a protective code. What that means is, if your truck is stuck in derate, blindly clearing this code with your laptop just isn't going to work. You actually have to investigate things like AdBlue contamination, frozen fluids, or blocked lines first. You've got to fix the mechanics before you clear the screen, or you'll just be chasing your tail.
And this brilliantly illustrates our next point, which brings us to the NOx sensors. You actually have two of them, SPN 3226 for the inlet and SPN 3216 for the outlet. Now, if you get an FMI 4, which means the signal is completely out of range low, the diagnostic protocol is fascinatingly simple. Manufacturer bulletins plainly state that if this specific code is present all by itself, don't waste hours troubleshooting. The module has already failed internally. You just need to replace the sensor immediately and take it for a test drive.
On the flip side, look at SPN 4364, which flags a very low NOx conversion in the SCR system. The diagnostic sequence here is super rigorous. Technicians can't just guess. They have to methodically rule out variables. They'll use a refractometer to ensure the DEF fluid quality is exactly between 28 and 36%. They'll compare pressure sensors. They'll even perform a parked regen to make sure the NOx efficiency actually climbs above 70%. It's a perfect example of systematic diagnostic problem solving in action.
Okay, let's head into Section 3, engine, air, and coolant.
So SPN 102 FMI 4 is a code you will definitely feel while sitting behind the wheel. Your manifold absolute pressure, or MAP sensor, is seeing abnormally low boost pressure. As a driver, you're going to experience sluggish acceleration, really horrible fuel economy, and excessive black smoke pouring out. And because that airflow is restricted, your DPF is filling up with soot incredibly fast. Now, while it could be a failing turbo, ironically, the most common culprit is often just a simple, cheap rubber boot that's leaking air in the charge system.
So the crucial point here is understanding severity. SPN 111 tracks your engine coolant level. With an FMI 18, the computer is just saying, hey, it's a bit low, but you can safely drive to the next stop. But an FMI 1? That means critically low, pull over immediately. And this often goes hand in hand with SPN 110, which triggers when your coolant temperature actually spikes. Knowing the difference between an early warning and a critical FMI1 is quite literally the difference between a quick fluid top-up and a completely melted engine block.
Section 4, Sensors and Drivability Issues. Let's jump into the CAD.
Your engine relies on incredibly precise timing, and that's dictated by the crankshaft position sensor. So SPN 190 FMI10 means your engine control module, the ECM, has completely lost the RPM signal from the crankshaft. When this happens, the computer is effectively blind to how fast the engine is spinning. And without that data, the engine simply cannot run properly, leading to an almost immediate stall.
And what happens when you press the gas pedal on your International or Volvo and absolutely nothing happens? Well, that's SPN 91 FMI4. The throttle pedal sensor voltage is dropping below range. Sure, it could be a completely failed sensor, but a lot of the time, it's something incredibly simple, a broken wire harness or a poor ground to the ECM. It's crazy to think that a single speck of rust inside a connector can completely disable an 80,000-pound truck, right? But it happens all the time.
Let's move to and see how this builds into our final segment, Section 5, Smart Diagnostics and Prevention. The source material gives us some fantastic, highly practical takeaways here. For example, just minimizing the amount of time you let your engine idle at low speeds drastically reduces the soot accumulation that triggers all those massive DPF and aftertreatment faults we discussed earlier. Furthermore, simply doing visual inspections of your wiring harnesses for any rubbing or corrosion during routine services, that alone can prevent those frustrating sensor communication codes long before they leave you or your driver stranded on the side of the highway.
So, I want to leave you with this final thought to reflect on today. When that check engine light comes on, remember, it's a protective message. Hooking up a diagnostic scanner and just hitting clear might make the light magically disappear for a few miles, but true maintenance means investigating the mechanics behind the screen. Are you just erasing the warning, or are you actually fixing the truck? Thank you so much for joining me on this explainer, and definitely stay tuned for more deep dives into the vital systems that keep our world moving. Catch you next time.